Hello students, welcome to aimstoday online classes. This is a chemistry session. Here we are discussing about the chapter chemical bonding. In the earlier sessions we have seen different kinds of chemical bonding, how they are being formed, their properties and different conditions where they are being formed. These all concepts we have seen about chemical bonding chapter. In this session we are going to see a practice sheet related to the chapter. Okay, let us see first the practice sheet 1, which includes all single correct answer type questions and conceptual understanding questions. Okay, let us start the practice sheet. First, let us go through the conceptual understanding questions. See the first question. SP overlapping is present in. Say, in which molecule SP overlapping is present? We know in bromine molecule formation, as bromine belongs to 7th group elements, it will be having its vacant orbitals in the p subshell. Okay, so both are bromine atoms only. Then the overlapping between these two atoms will be pp overlapping. If you see H2 molecule, in this the atom hydrogen has in its vacant orbital or on half filled orbital in s subshell. Both are hydrogen atoms here. So when these two hydrogen atoms approach each other, they undergo SS overlapping. Whereas if you see oxygen has its half-filled orbital in its p subshell. So here also we can expect pp overlapping between the two hydrogen atoms. Whereas if we see in HF molecule, hydrogen has its single electron or unpaired electron in its s subshell, whereas fluorine has its unpaired electron in its p orbital, to pz orbital we call that. So in this molecule, when these two hydrogen atom and the fluorine atom approach each other, they undergo sp overlapping. So sp overlapping is present in hydrogen fluoride molecule. Okay, next. Next question. Which of the following is not correct? See here some statements are given. We have to identify which statements are correct or incorrect. Let us find out. See the first one. A sigma bond is weaker than pi bond. Is it correct? No. Because a sigma bond is formed by the end-to-end overlapping of atomic orbitals on their axis of nuclei, and hence there will be extent of overlapping maximum. So the formed sigma bond will be stronger bond, whereas a pi bond is formed by the lateral overlapping of atomic orbitals that are perpendicular to their axis of nuclei, and hence the pi bond is somewhat weaker than sigma bond. So here it is given reverse way. So it is wrong statement. So the second one, a sigma bond is stronger than pi bond. This is correct. A double bond is shorter than a single bond, of course, because when number of bonds between the two atoms increases, the attraction between them increases more, and hence both the atoms comes close a little, and hence the distance between those two decreases. That we says bond length decreases. That's why a double bond is shorter than a single bond. I think the next statement also same repeated. Okay, this also will be correct. Now, only one incorrect statement among these four is this. Okay, next one. So the next question: shape of a molecule is decided by, with which it is decided. So the shape of a molecule depends upon the number of sigma bonds present on the central atom of the molecule. Only sigma bonds decides the shape of the molecule. Pi bonds do not have any effect on the shape of the molecule. Just they can change the length or bond length, but there is no effect on the bond angles or shapes of the molecules. Only sigma bonds decides the shape of the molecule. Next one, the orbital overlapping is maximum in. So in which molecules the orbital overlapping will be maximum? So if you understand what kind of overlapping existing in these molecules, then we can say where the extent of overlapping is maximum. If you see in the molecule Cl2, the overlapping we can say as pp overlapping, isn't it? If you see in the hydrogen iodide, hydrogen has s orbital vacant with single electron, and iodine has its half-filled orbital into p subshell. So in this molecule, the overlapping will be sp overlapping. In the similar way here, in the HCl also, sp overlapping. Whereas if you see in the HBr, it is also just like that. Hydrogen and a halogen, sp overlapping. Now, we know the extent of overlapping will be greater in p orbitals than s orbital overlapping. So, if you see in the molecule Cl2, both are p orbitals. So, there we can expect the extent of overlapping maximum. Okay, extent of overlapping will be maximum in case of pp overlapping. It is somewhat less in sp overlapping, and still it is less in ss overlapping. So, maximum in pp overlapping. Okay, next one. Which combination of atoms can form a polar covalent bond? So, what is meant by a polar covalent bond? The covalent bond in which the electron pair is unequally shared, or in which electron pair is not equally shared, or we can define the other way also, the covalent bond which is formed between two different atoms, or between the atoms which are having different electronegativities, will be a polar covalent bond. So such kind of atoms, if they share a pair of electrons, the atom which is having greater electronegativity will pull the pair of electrons towards it, and hence the bond becomes polar in nature. Now see here, the molecule or the combination of atoms where the atoms with the different electronegativities are mentioned. See, both are hydrogens here. So here the covalent bond formed will be non-polar covalent bond because similar atoms. And if you see HBr, hydrogen and bromine, both are non-metal atoms and they participate in the covalent bond formation. But here bromine is being more electronegative, it pulls the pair of electrons towards it, and hence the bond formed between these two atoms will be a polar covalent bond. Whereas if you see nitrogen and nitrogen, they form a pure covalent bond because of the both same atoms. Okay. And if you see in case of sodium and bromine, sodium is a metal which is ready to lose electrons, whereas bromine is a non-metal which accepts those electrons, and hence they result in the formation of ionic bond. So no case of covalent bond formation in this. Now the only molecule with polar covalent bond is hydrogen bromide. Okay. Next one. Which of the following pairs do not form a dative bond with each other? Say which combination results in the formation of a dative bond? We studied that there are certain conditions for the formation of a dative bond. One it is there should be an atom or molecule with a complete octet on its central atom, and there should be at least one lone pair of electrons. And the other atom or molecule should have still vacancy for two more electrons on its central atom to get octet. If you see here, nitrogen can donate a pair of electrons in this ammonia, and it is ready to accept a pair of electrons. So between these two, there is a chance to form a dative bond. And if you see H2O, in this also, oxygen has two lone pairs of electrons which can donate, hydrogen plus ion which can accept this pair of electrons. So they also results in the formation of a dative bond. Here also in ammonia boron trifluoride, ammonia donates a pair of electrons, whereas boron trifluoride accepts its pair of electrons, and hence results in the formation of a dative bond. And what about here, H2 and Cl2? No one is ready to accept a complete pair of electrons. Each are ready to accept one more electrons by covalent bond formation, and hence they result in the formation of a single covalent bond, not coordinate covalent bond. So this is a molecule which do not form a dative bond. These two atoms They do not form 8A2 bond. Just they can form normal covalent bond or non-polar covalent bonds they can form. Right? That is the answer now. Next one. H2O has higher boiling point than the corresponding hydrides from the same group. This is because water has. What water has specially from the remaining all elements, oxides, hydrates from the sixth group. See, these all are the hydrates of sixth group elements. Oxygen, sulfur, selenium, tellurium. These all are sixth group elements. So these all are called hydrates of sixth group elements. Out of these all, abnormally, this H2O, hydrate of oxygen, which we commonly call as water, has a high boiling point when compared to the remaining all. This high boiling point of water is because of the existence of hydrogen bonds between the water molecules. We have studied what is meant by water molecule hydrogen bond. The electrostatic force of attraction between the electropositive hydrogen atom of one molecule and the electronegative atom of another molecule is called hydrogen bonding. So because of the existence of this hydrogen bonding, water has a little greater boiling point than the expected. Okay, due to because of hydrogen bonds existence. Next one, mobile electrons within bonding networks best describes which type of bond. So mobile electrons within the bonding networks represents sorry, metallic bond. We know in the metallic bond formation all the metal ions will be surrounded by mobile electron cloud around them. So that represents metallic bonding. Next one, hybridization of one s orbital and one p orbital results in the formation of. What do the result? We know one point that the number of orbitals intermixing each other will be equal to the number of hybrid orbitals formed in the hybridization process. So here one s orbital and one p orbital they are intermixing, and hence they result in the formation of two hybrid orbitals. They are named based upon the type of orbitals intermixed, one s, one p, and hence these two hybridized orbitals formed are called sp hybridized orbitals. Now we can say by the combination of one s and one p orbital, they result in the formation of two sp hybridized orbitals with an angle of 180 degrees. That means we say linear shape. Okay, linear shape they form sp hybridized orbitals. Okay, next, which of the following is correct with respect to SO2 molecule? So they're asking what type of bonding exists in the SO2 molecule according to valence shell electron pair repulsion theory. To predict the shape of the molecule, we have to first understand how many bond pairs of electrons are there and how many lone pairs are there on this central atom. So that we can say we can predict its shape. So based upon that, it is given question here. In this, the first letter A represents the central atom and B represents the number of bond pairs on the central atom, and E, actually it is to be E. This E represents the number of lone pairs of electrons on the central atom. Now let us see what kind of molecule is this. Means how many bond pairs and lone pairs are there on the central atom nitrogen in SO2 molecule. Say this is a structure of SO2 molecule. So while predicting the shape of the molecule according to VSCPR theory, we consider multiple bonds are also between the two atoms as a single bond, because there is no effect of multiple bond formation between the atoms in predicting the shape. So now we can say this can be considered as one bond pair altogether, and this can be considered as one bond pair. Now on the central atom sulfur, now there are two bond pairs that can be represented like this AB2, and at the same time there is one lone pair of electrons also on the sulfur. We can say this as E or E1, AB2E. So this is a molecule with AB2E type, and its shape is bent shape. Okay, where it is represented AB2E type molecule and it has bent shape. This is correct. Okay. Next, which of the following is a correct pair? See here, some molecules are mentioned and their shapes are also mentioned. Let us try to predict what shape they are having. How can we predict the shape of a molecule? Based upon the number of bond pairs and lone pairs present on the central atom. If you see the first one, BeCl2, in that molecule, the central atom is beryllium. If you see beryllium in the central in this molecule BeCl2, it has two lone pairs of electrons without any lone pair, two bond pairs of electrons without any lone pairs, and hence we can say its shape is linear shape because both the bonds they'll try to attain maximum distance one to another, and hence they'll be in the linear shape with 180 angle. And this is next molecule ammonia. In that central atom is nitrogen, and it has three bond pairs, and there is one lone pair also. So because of this lone pair, the three bond pairs will bend down, so it gets a pyramidal shape. So the shape of the ammonia molecule is pyramidal, but they mentioned here as linear. It is incorrect matching. Trigonal pyramidal shape it is called. Ammonia has trigonal pyramidal shape because of the existence of three bond pairs and one lone pair. And what about carbon dioxide molecule? Central atom is carbon and it has two bond pairs. We told here according to Vesper theory, while considering the shape of the molecule, we have to assume these multiple bonds are also as a single bond, single unit. So it has two bond pairs without any lone pairs. Now the bond angle will be 180 and the shape will be just like BCl2. It also will be having linear shape. So, but here it is mentioned wrong matching. Tetrahedral it is mentioned, which is wrong, isn't it? And BF3 molecule. In this central atom boron has three bond pairs and there are no lone pairs. And hence, it will get the shape trigonal planar shape. Okay, it gets a trigonal planar shape, but it is mentioned here octahedral shape. Only BaCl2 linear combination is correct. Okay. Next, let us go through one more question. The molecule whose shape is based upon lone pairs. See, generally, the shapes of the molecules depends upon the bond pairs and lone pairs present on the central atom of that molecule. See here, the molecule in which the central atom has at least one lone pair of electrons on its central atom. That's a shape that molecule's shape will be dependent upon the lone pairs also. See here the first molecule CH4. Is it having any lone pairs on the central atom? No. So its shape won't be dependent upon the lone pairs of electrons. It depends only upon the number of bond pairs present on the central atom. See the next one, carbon dioxide molecule. Okay, if you see water molecule, it has two bond pairs, two lone pairs. So its shape is depends upon these lone pairs also. So it is correct answer. Let us see the remaining two also. If you see carbon dioxide, in this also the central atom has no lone pairs, only bond pairs are there. So its shape also won't be dependent on the lone pairs. And if you see next SF6, sulfur hexachloride it is called. In this, central atom is sulfur. It also has only 6 bond pairs and no lone pairs. So its shape won't be dependent upon the lone pairs at all. Only the molecule water, its shape depends upon the lone pairs present on the central atom oxygen. Okay, that's why the shape is being bent shape. If there are only two bond pairs, it may get a linear shape. But because of these two lone pairs, these bond pairs will be pushed down and it gets a bent shape or V shape, which is also called angular shape. Okay, next. Now let us go through the single correct answer type questions. See the first one. Electrovalent compound among the following. What is meant by electrovalent compound? It is also called as ionic compound. Generally, ionic compounds will be formed between electropositive metal atoms and electronegative non-metal atoms. See, in which this combination is present. Here it is, calcium oxide. In this, calcium metal loses electrons, whereas oxygen non-metal gains those electrons, and hence they result in the formation of electrovalent or ionic compound formation. Whereas if you see the remaining all are covalent compounds because they are formed between the non-metal atoms. H2O, both are non-metals. Carbon dioxide, both are non-metals. HCl, in this also both are non-metals. So these all molecules are of covalent type. Only calcium oxide is electrovalent compound. Next one. In a nitrogen molecule, the two atoms of nitrogen are bonded by. So what type of bonds are present in the nitrogen molecule? We know in nitrogen molecule, each nitrogen atom contributes 3 electrons for bond formation, and hence they form a triple bond between those two. Out of this triple bond, one will be a sigma bond and the remaining two will be pi bonds. Between any two atoms there exists only one sigma bond and the remaining two are pi bonds. Okay, there is one sigma bond and two pi bonds in the nitrogen molecule where it is one sigma and two pi bonds. This is correct. Okay, next, formation of pi bond. What happens by the formation of a pi bond? Pi bond results in the formation of generally multiple bond. So we know as multiple bonds are formed between two atoms, both the atoms approach each other a little more and hence bond length decreases. So the formation of a sigma bond results in the decrease of bond length. Okay, next, a double bond is made up of. So any multiple bond will be containing one sigma bond. Remaining will be pi bonds. So double bond means two bonds. Out of those two, one will be sigma bond, the other one will be pi bond. Where it is here, one sigma and one pi bond. Next, all single bonds are all the single bonds are sigma bonds because whenever two atoms approach each other for the bond formation, first they result in the formation of a sigma bond only because their orbitals they overlap on their axis of nuclei, that is end to end, that results sigma bond formation. The further bonds result in the formation of pi bonds. So the first bond will be sigma bond. The number of sigma and pi bonds in carbon dioxide molecule is, observe once carbon dioxide molecule, the number of sigma pi bonds. In the carbon dioxide molecule, there are double bonds between the two carbon and oxygen atoms. So out of double bond, one is sigma bond, the other one is pi bond. In the same way here also. So overall, there are two sigma bonds and two pi bonds in carbon dioxide molecule. Next, which substance represents a molecule that can combine with a proton? So generally proton can participate in the bond formation by accepting a pair of electrons. So the molecule or ion which is ready to donate a pair of electrons that can participate in the bond formation with H plus ion with the dative bond. See here in the given molecules, out of these all, ammonia molecule has a single electron pair on the central atom nitrogen. So that can donate that pair of electrons to H plus and thus they form a dative bond. Okay, ammonia can participate in the bond formation with that. Okay, next, which of the following contains both polar and non-polar bonds? So if the bond is formed between two similar atoms or atoms with the zero electronegative difference, then the bond will be non-polar bond. If the bond is formed between two different atoms or the atoms with the different electronegativities, results in the formation of polar covalent bond. Now if you see in the ammonia molecule, all the bonds are between different atoms. See here, this is between nitrogen and hydrogen. It is also between nitrogen and hydrogen. Here also the same. So between the two atoms in the bond formation, electronegative difference is there. So all are polar bonds. If we see in the case of HCN, in this also the bonds are between two different atoms. So all are polar covalent bonds. Between here carbon and nitrogen also, both are having electronegativity difference and results in the formation of polar covalent bond. But if you see H2O2, which we call as hydrogen peroxide, here between oxygen and hydrogen, the covalent bond formed will be polar in nature, isn't it? Because out of these two, oxygen is more electronegative, hydrogen is less electronegative, and hence the bond will be polar in nature. And this is also polar bond. But if you observe the bond between oxygen and oxygen, here both the atoms are having same electronegativity because same atoms. So thus the bond will be non-polar covalent bond. Okay. In that way, this molecule is having non-polar covalent bond as well as polar bonds. Right? This is a molecule. If you observe a methane molecule, here also four covalent bonds are between dissimilar atoms, and hence these are also considered as polar covalent bonds. This is the only molecule with the polar as well as non-polar covalent bonds. Okay. Next, the distance between the nuclei of the two covalently bonded atoms is defined as. So how do we define that? The distance between the nuclei of two covalently bonded atoms, that is defined as bond length. It is called bond length. Okay, next. The percentage of p character in sp3 hybridized orbitals. See, sp3 means it is formed by the combination of or intermixing of one s orbital and three p orbitals. So out of 4, 3 are p orbitals, 1 is s orbital. So out of 4, 3 are p. Then how can we say the percentage? 75%. 3/4. Okay? 75%. Next, the bond angle in BF3 molecule. BF3 molecule means boron trifluoride molecule. In this, the central atom is boron and it has 3 bond pairs, no lone pairs. And hence the shape will be trigonal planar shape. If the shape is trigonal planar shape, then the bond angle will be 120 degrees. Okay, it has 120 degrees bond angle. It is correct answer. Next, which one of the following is a linear molecule? To be linear, what should be there on the central atom? There should be two bond pairs and no lone pairs. Let us observe the structures of these molecules once. Ammonia molecule has three bond pairs, one lone pair. So the shape will be pyramidal shape. Trigonal pyramidal shape it is called. And if you see sulfur dioxide molecule, in that there are two bond pairs and one lone pair. So the shape will be bent shape. What about carbon dioxide molecule? It has two bond pairs, no lone pairs in central atom, and hence the shape will be linear. So this is correct answer. What about H2S? In that central atom sulfur has two bond pairs, two lone pairs. So the shape will be bent or angular shape. Only the one molecule with linear shape among these is carbon dioxide. Okay. Next one. AB4E2 type of molecule with a square planar shape is. AB4E2 means the central atom A should contain 4 bond pairs, 2 lone pairs. What is that molecule among these? Let us find. First, if you see ClF3, chlorine has 3 bond pairs, 2 lone pairs, but not 4 bond pairs. If you see SF4, sulfur tetrafluoride, central atom sulfur has 4 bond pairs, but lone pairs is only 1. If we see water molecule, 2 bond pairs, 2 lone pairs. But if we see the molecule XeF4, xenon tetrafluoride it is called. In this central atom, xenon has 4 bond pairs and 2 lone pairs, and hence it will be having the molecular shape square planar. means along with the xenon, remaining 4 fluorine atoms also will be in the same plane in the square shape. And above the plane one lone pair and below the plane one more lone pair. So the shape is called square planar and it is having type of molecule AB4E2. So this is correct answer. Okay. Next one more. The shape of AB3E type molecule. AB3E type means it should have 3 bond pairs and 1 lone pair on the central atom. So if there are 3 bond pairs and 1 lone pair, then the shape of the molecule will be trigonal pyramidal or just pyramidal we can say. This is a molecule. Ammonia we call it. Okay, it is having 3 bond pairs and 1 lone pair. It is of AB3E type molecule. So its shape is called pyramidal shape. Okay, here it is correct answer. Pyramidal shape. Okay, thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates on recorded videos. And even please visit our website also, that is aimstoday.in, for information about online classes, quizzes, live worksheets, do-it-yourself activities, English classes, reasoning, and coding. For this all, you can watch this website aimstoday.in.